Alright, time for another draftphysics.com, debatephysics.com, also video presentation. To the cranks. The people who wish to propagandize for absolute nonsense physics that can be in so many ways demonstrated to fail. So it doesn't move rocket ships, it doesn't work with ballistic pendulums, those are the obvious ones, it disobeys the law of the lever, it breaks all conservation laws, this idea of 1/2 mv squared. It isn't always conserved. They both aren't always conserved. It can't both be conserved in most cases where you transfer energy between two dissimilar objects. Fact. So my previous video, I went through all the examples, blah, 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 blah. They just ignore those videos. And so anyway, I'll deal with disbar and then Falwell and then a commenter, I guess. And I guess I should make a web page of just this kind of nonsense because it's just, these are the counter arguments and they're just so bad. So now we're back to floral foam. So disbar has decided to do floral foam experiments. Now nowhere has it been established that foam is some sort of great equalizer that perfectly measures energy and velocity doesn't matter. I've compared it to a bunch of surfaces. It's like pieces of wood. And so, or even cinder blocks. And you know that velocity matters when you want to break those. So the higher velocity will break a board. Low velocity, same force, but at a low velocity, won't break the board. So we know velocity matters. And foam might be just a terrible medium, just as I could make a cornstarch medium, where exactly the opposite would be true, that anything with a high velocity would be penalized, and things with a slower velocity, same momentum, would be rewarded. And the fact is, so you can make mediums that cheat. Now, the whole reason why Joule is famous is because he realized this problem, that there's not just some easy way you can test. You just don't tie a rope to a sheep or something and then pull on it and see how much the sheep pulls or moves. There's not these great ways to just test for something's true capacity to do work. And that's why he had to contrive a way to find an absolute, a way of grabbing it all. And that was the idea of the Joule tank. Now, the failure was that he didn't test anything but experiments in gravity, and he really didn't understand gravity, so he didn't understand that you drop something slower, it'll actually be in the gravity longer, and therefore it'll actually collect more force. It's just a fact. You can move a light thing slowly in gravity and collect the same force as a heavy thing moving quickly. If it moves quickly, it means you didn't pull on it very hard. If it moves slowly, it means you're taking a lot of energy out of it. Ramps that things roll down get hot, meaning, well, you can't get the same velocity as dropping it in free fall if you were making the same amount of energy because you used up a bunch of energy to heat the ramp. So obviously, slowing it down slowing it down in the sense it takes longer for it to acquire the same velocity means it actually did collect more force and it lost it to friction. All right, anyway. So, this is physics. You gotta be able to do some of these. You gotta be able to understand there are variables in experiments and you do have to account for their existence and explain how they either have an effect or they don't have an effect. You can't just pretend them away. Alright, so a key feature in this is he has a little round thing glued onto the metal thing. Now I assume he's doing this for theater, like he's going to redo the experiment without the little round thing on the end to prove that the round thing doesn't matter to foam anyway. Now the fact is that there's just an absolute fact that Clay Brozo did these experiments. The round thing matters. So it's not just a fake idea that whether it's got a surface that changes depending on how deep it goes into the surface, it matters. Okay. Now, it's not going to matter if it goes 10 inches into the surface, but it's going to matter on the, if you're just denting the surface, and in this case, he's just, again, denting the foam, the surface of the foam. So he doesn't establish that the one mass going to velocity, his numbers aren't twice as much. So he doesn't establish that it has twice as much kinetic energy. He gets like 1.5 times as much. So it doesn't establish his truth at all. And so again, it's just more noise, more verification of nothing. And for what purpose? And again, to contrive the round thing, after I've made so many videos about the fake Deschardelet experiment and how this is what physics went all wrong in the first place, is making these assumptions that it doesn't make a difference when, of course, it makes a difference. A pointy arrow will, in fact, go deeper into something than a dull arrow. It's just an absolute fact, and it doesn't mean the arrow has more energy. It means how you're applying the energy is more effective at penetrating it. And, if they can't even accept that simple truth, well, I probably shouldn't interact with them at all. And so it's my bad for even interacting. So I'm assuming this is for some sort of got you theory where he wants me to say, see, round objects, blah, 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 when the real argument is, when did we test foam? So I will argue that some of this can be negated because we do know, okay, we don't have to build a joule tank. The fact is, there are ways of testing that, we can establish them to be pretty good if you can establish the velocities going into the experiment. So that's the two tricks. The trick is first creating a circumstance where you can be sure of the velocity, and then creating a circumstance where you can measure the outcome velocity. And so there's been numerous attempts at doing a fair experiment where you launch objects off of a surface and how they fall. Okay, the projectile motion is kind of guaranteed. So if you give something twice the velocity, you can be fairly assured it will go exactly twice the distance. So you get 1 unit of distance for 1 velocity, 2 units of distance for 2 velocity. That kind of works because friction isn't really involved at all, and all you're doing is taking advantage of the fact that you have a constant falling rate that's equal for all objects. And so now it's just a matter of how much, they're going to have the same amount of time before they're going to hit the ground. So no matter how far away it is, its falling time will be exactly the same. So it's pretty reliable. And so all that really has to be established is what was the velocity going in if you're going to measure velocities going out. So, and that's the problem. So the idea would be, I think, the more perfect experiment would be to have a lever on that cliff and to have appropriately attached objects so you can be assured that they don't fly up in the air or they don't do some other thing to change this very consistent outcome of a constant rate. I mean, obviously if you shoot the object up, you're going to get a different distance, or down for that matter. You want a perfectly linear launch, and if you don't have that, you don't have a fair experiment. So this is doable, but they won't do it credibly. So they use weird little spring launching devices, or they make crappy levers out of some kind of wobbly stick. They do something to break the experiment. Now, the other option, which I think is even better if you have the technology, is just to measure the speed of a lever. So you can negate the whole argument, all right, by just establishing that the lever speed will tell you how fast the lever moved, and how fast it moved with a mass at some location will tell you, how. So you don't even have to launch the object. You can just stick a mass on a lever, so it's permanently stuck on it. Don't let it touch any Don't let it touch the ground. Have it suspended so nothing touches the ground. Alright, and then push your lever, and you'll know that if it moves the same speed, okay, for these two experiments, the two mass moving one distance at one distance on the lever, the one mass moving two distances, okay, at two distances on the lever, would be the same momentum. There would be conservation of momentum. The lever would move exactly the same, so you would register at exactly the same time if you were just measuring some point out here in terms of how much it moved. So that's another experiment that could be done, get a nice clinical result. But we probably aren't going to see that. Now, Brozo's it promised to do, but it doesn't sound like he's going to do it. A redo of his experiment, which pretty much did demonstrate that it does, momentum is conserved. The lighter object, the half mass, will go almost twice the velocity that the two mass, twice the mass went, with the same force in. He promised he's going to redo the experiment, but there's no evidence he is. It's an empty promise, apparently. Alright, so we'll deal with Falwell next, I believe. Yeah, I think so. Alright, so this is the Falwell video. And he's titled Draft Science Finds Yet More Free Energy. So there's no free energy. None of this, all these fake titles, these phony ideas that they've demonstrated I said something or did something to indicate something. It's just all lies. And, in this case, he's quote mining videos now. Extracting bits out of the context to demonstrate something, and it's just lying, frankly. Yes, these are unscripted videos, and sometimes I'll say something not perfectly articulate, but usually I catch it and I make the point in some other way to clarify what I'm arguing. So I will show that part. So I'm sure in his video, which I haven't watched, this piece of it is missing. This simple argument that I made quite clearly in the video, and they just pretend it didn't happen, and it did happen, because this was the simple point. So you could put it in very close. Alright, some sort of catastrophic failure. So I did play all of Falwell's video, did read the comments, and even a comment on my video, and unfortunately it's all gone. So I'm not going to bother, just because I didn't realize that Falwell's video was just all lies and nonsense. So they're perverting what I stated in the video. When I made this drawing, you can see these little dots here, indicating that you can move a mass on a lever. I was talking about moving the same mass and just seeing how much velocity you would get. And I was making a simple argument that the closer in it is on the lever, that the lever has to move faster, that if you measured the outside of the lever, if you measured its speed, it has to go faster to move the same speed of the object. So you want to get a maximum speed. So clearly I'll be describing it here. So I never indicated in the video that I could just take a one mass and I move it two distances, and the one mass with the same force will move twice the velocity, or with the same force the same mass will move 4 times the velocity. Obviously I've demonstrated what equals what. I've made these arguments thousands of times, literally. The one mass going 4v is the same as the 4 mass going 1v on the other side of the lever. So I've never made any argument that I think you don't have to conserve momentum. So it's all just such a silly, stupid lie. And they just quote mine the video to imply I said something else. So right after the clip he plays, I say this. So there's no doubt about what I was talking about. To go 50 miles an hour, let's say, the object to go 50 miles an hour, it can't go 50 miles an hour here, 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 no matter where I put it, because the lever itself has to move a different speed for it to go 50 miles an hour. So if I wanted to get a peak velocity, there's a place on the lever where the amount the lever uses and the amount the object gets, okay, are in perfect balance, in the sense that you've minimized the motion of the lever and you've maximized the motion of the mass. So there is a point somewhere on this lever where you're going to get a peak velocity. That was the argument. All right, so I made it clear. That's the argument. So the argument is kind of just simple, that you have to account for the other variables in an experiment. If your lever weighs half as much as the objects you're moving, then obviously the amount of movement in the lever is consuming a lot of energy out of the experiment. So that was the only argument being made, is that you have to account for how much you're losing to the velocity of the lever itself. And it's just a simple truth that the further in a mass is, the more velocity the lever has to move it the object the same velocity. The lever moves very slowly on the inside and very fast on the outside because of the greater distance it's moving. So to go 50 miles an hour for something on the inside means the lever itself on the outside is moving 300 miles an hour. That was the point. And the point is, if I can put the object further out, I can reduce how fast the end of the lever is moving. And also I was pointing out that you could do this experiment where if you wanted to test the velocities of something, you could just, put a 1 mass and see how fast the lever moves. And then put a 2 mass, put a 2 mass at 1 distance, and then put a 1 mass at 2 distances, and theoretically the lever should move at the same speed. That was the point being made in the video, and they completely distorted and lie about it. And it's claimed that I was saying that somehow you could take the same mass and just move it on a lever and gain free momentum. I've never argued for free momentum, never argued you could lose momentum, never argued you didn't absolutely always have to conserve momentum, and momentum is force. I've made those arguments over and over again and made them as clear as could possibly be made. And for somebody to quote me in a video to imply I'm saying something different is just such lying shystery. Alright, so there's no point in reading it. No point in playing it, because that's all he's saying. He's taking one clip and pretending, if you pervert that one clip out of the context, that somehow I was saying I could make the same one object go 50 or 100 or 150 or 200. I wasn't arguing that at all. So it's just a pathetic lie. All right, Brozo did comment, but he was just saying the same thing in the video, that somehow I did say that. That I somehow did say in the video you could make the same object go different velocities, substantially different. When my argument was there's just a certain percentage you're losing to the motion of the lever, and that percentage has to be understood. That's all. There wasn't anything else in the video except an explanation that the lever absorbs some of the energy, and it varies depending on the location of the mass. Not a challenging argument. No more challenging than the pointy arrow versus dull arrow challenge. All right, so we'll be done with that. And then the one comment on one of my videos that was just such useless rubbish, but I might as well find that. And all right, Spencer Griffith. This was just so stupid. Okay. I've pointed this out before, but you ignored it, so I'll repeat. So there's nothing you pointed out, and you didn't pay any attention to the argument or the video. So he's arguing that somehow if I have a brick wall and I pull a rubber band with an object and I let it go, it'll go a certain velocity crashing into the brick wall, say 100 miles an hour. My argument and the facts are that if I took 2 objects and I create the same stretch in a rubber band, now I have 2 objects, that they're going to go half that speed. And they're going to collide. It'll feel like 100 miles an hour to somebody standing in between the 2 of them, because they're both going half the speed and they're one mass. So it's going to still be 1 plus 1. It's going to be 1 unit of velocity and 2 units of mass. And in the other case, it's going to be 2 units of velocity and 1 unit of mass. So the mass will crash into the wall at twice the speed. Now, Uriney's video clearly showed that to be absolutely the truth. So this isn't even debatable. You're a pathetic liar. That's all that can be said. In Uriney's experiment with the wooden blocks pulled together by a rubber band, so in the case where they're pulled together, it's a mass plus another mass. And in the case where only one of them moves. So again, their argument is that somehow it moves one object being pulled by the same force, moves at the same velocity as two objects pulled by the same force. And obviously they don't. It's ridiculously stupid. All right, the two-mass block travels. So there's no two-mass block anywhere in, the argument is obviously if one of them is a one mass and one of them is a two mass, the two mass will go half the velocity. And that isn't even disputed by Professor Lewin. So that's a non-arguable position from your point of view. You can't argue that conventional physics says otherwise. The two-mass object will be going half the velocity. If I made it a three-mass, it'll be going a third the velocity. If I make it a four-mass, it'll be going 1/4 the velocity of the other object. All right, so the two-mass block travels 1 unit of distance. So we know that the units of distance don't mean anything. We know what their velocities are at impact, and all that matters. The four-mass will be going 1/4 the velocity. The one-mass will be going 4 velocity. All right, the four-mass block travels 2 units. This means that the one-mass block's pulled by twice the amount of rubber band. So he's saying that twice the force went into one of them, and it doesn't. That's not how springs work. It's not how any of it works. He's claiming Newton's third law is violatable, that somehow the momentum isn't equally shared, when obviously, of course, it is. Okay. With the same tension giving twice the energy. So we already know what their velocities are. It's well established. You can see the velocities in the video. You can see the velocities based on the distance traveled. So it's just a lie to say there's any dispute whatsoever. The four mass goes one tiny little bit of distance. The one mass goes a huge 4 times the distance. Fact, absolute fact, 4 times the velocity versus 1/4 the velocity. Just a lie to say anything else was demonstrated in the videos. You can literally cut the rubber band in 2 pieces at the point of collision. So at the point of collision, the rubber band's irrelevant. It's no longer pulling. They stop pulling some when they're a foot apart. So it's just 2 objects with a velocity crashing into each other. So it's as clean an experiment as you can get in a way. You just have 2 objects with momentum crashing into each other. And the fact is they have equal momentums, and the impact proves they have the same capacity to move each other, and it absolutely proves that the thing with 4 times the kinetic energy can't do any extra work. All right, attach a loose ends to something that doesn't move. So we know that if I attach it to something that doesn't move, it will go twice the velocity. And repeat the experiment. The blocks would gain the same velocities they did before. So it's just an absolute lie. It was in Uriney's video. I played it. That's not how it comes out. 1 block, 1 stretched rubber band, brick wall, 100 miles an hour. 2 cars, same stretch, 50-50. Fact. You're a liar. That's all that needs to be said. You're a waste of time. Because what you're arguing isn't even your own physics. It isn't the conventional physics I'm arguing against. They don't say what you say. Liar. All right, so till the next time and such and so forth. We'll leave it at that. So you're spared 40 minutes of crap. So lucky you. An extra 40 minutes. It was all crap. Having to make these arguments is all a waste of time. Again, I should have to prove that floral foam isn't the ideal absorption medium. That there might be some better way to test how much energy something has. Yeah, no, I shouldn't have to make those arguments. They should establish that this works. It's a great way of collecting energy because it's just as fair to fast things as slow things. They should have to demonstrate that, and they feel no obligation. They just say, I'll do more gimmicks. Gimmicks are great. That's what science is, gimmicks, fooling people. That's what you get little silver stars for. Scum. That's all that can be said. Scum.